Hello, YouTube. I'm going to go back and touch on a video um, that I have previously recorded about the cosmic microwave background radiation. The standard model just died. Back when WMAP, the probe that they sent out to do experiments and gather data on the cosmic microwave background radiation, um, which is the glow that happened after the Big Bang. And it was supposed to tell about like the age of the universe, the how much dark matter, how much matter, all of these pieces, very important pieces of data that really stabilized, that held up the Big Bang um, theory. And as all the information started coming back in, it was all skewed and nothing like what they thought it was going to be. I mean, literally, like killed the standard theory, but they couldn't let it go, so they were milking it and still just told a bunch of lies about it. But um, they they came out with some new information from about the Hubble constant that that really put the nail in the coffin. But I'm going to go back and let's listen to my previous video and hear about uh, the beginning of this whole thing. Whatnot on our cosmic microwave background. Most cosmologists, sorry, I'm drunk as piss, I can't talk, will not admit it publicly. Perhaps over a beer, they would tell you what is happening. Yeah, because it's shutting them down hard. Observations over the last 50 years, culminating with the Planck satellite results, March 2013, set modern science on a counter-revolution leading closer to ideas formed 500 years ago. Today's cosmology Today's cosmology is based on two broad principles. The Copernican principle, we are not in a special place in the universe, and the cosmological principle, the Copernican principle plus isotropy, which we talked about. The view from anywhere in the universe looks all about the same. Starting with early studies of the cosmic microwave background, and in recent years culminating with results from the Kobe, when the WMAP satellite scientists were faced with a signal that the larger scales of the universe, a signal that pointed right back at us, indicating that we are in a special place in the universe. Without getting overly technical, the Copernican and cosmological principles require that any variation in the radiation from the CMB be more or less randomly distributed throughout the universe, especially on large scales, resulting from the WMAP satellite in the early 2000s. Yeah, I thought it was about 96, but maybe it was 2000. Indicated that when looking at large scales of the universe, the noise could be partitioned into hot and cold sections. And this partitioning is aligned. Now pay attention to this part here. This is important. This partitioning is aligned with our ecliptic plane and equinoxes. This partitioning and alignment resulted in an axis through the universe which scientists dubbed the axis of evil because the damage it does to their theories. The axis is aligned to us, Lawrence Krauss commented in 2005. Quote, but when you look at the cosmic microwave background map, you also see that the structure that is observed is in fact in a weird way correlated with the plane of the Earth around the Sun. Is this Copernicus coming back to haunt us? That's crazy. We're looking out at the whole universe. There's no way there should be a correlation of structure with our motion of Earth around the Sun. The plane of the Earth around the Sun, the ecliptic, that would say we're truly center of the universe. Okay, what they found that
everything in the universe is situated in relation to us, Earth, us. Everything is like lined up around us.
Most scientists brush the observation off as a fluke of some type, and many theories were created to explain it away. Many awaited the Planck mission. The Planck satellite was looked upon as a referee for these unexpected and unwelcome results. A little more background on this. There was a movie that came out called The Principle when these first WMAP readings came out that just astonished everybody and pointed to the fact that we are at the center of the universe. And not only that, everything in the universe is lined up like on shelves around us. Like everything is in relation to us. We are, and that just flipped everybody's wig. They couldn't handle it, so they just kept sending shit up there to do the same damn test over and over again, trying to figure out what it couldn't be right. There had to be some either contamination or there had to be some kind of fault in the instruments. I'll go on here. Planck reported back, though, this was they started looking at the smaller scale of this Planck satellite, because hence Planck was the small guy. Reported back and in fact verified the presence of a signal in even higher definition than before. Basically,
now keep in mind here, this has been going on since the 2000s. They got the initial data back. They sent 5 more probes and experiments up to confirm this data. Now we're rolling on 2013. The data comes back. It can't be it can't be dismissed any longer at this point. So it's basically killed the standard model.
this satellite came back and said 110%, yes, this is right. There are cosmologists and scientists who recognize the signal for what it is, and recent articles have started talking about the need for some new physics to explain the results. Even on the Planck mission website, Professor needs to get a better name states, our ultimate goal would be to construct a new model that predicts the anomalies and links them together. But these are early days. So far, we don't know whether this is possible and what type of new physics might be needed, and that's exciting. Other observations have independently validated the axis of evil in recent years, and this adds credibility to the CMB observations. These observations include galaxy rotation alignments to our tiny part of the universe. Very recent reports include observations of alignment between sky distributions of powerful extended quasars and some other subclass of radio galaxies, and a plane passing through the 2 equinoxes and the North Celestial Pole. Also, anisotropy and of cosmic acceleration and union 2 type I supernova appear to be aligning with the CMB features. All this supports the contention that the Copernican principle and cosmological have effectively been invalidated without even discussing the quantization of various astronomical features about us, which further support the contention.
Okay, so basically, you can get the gist of that. This data, these findings, have killed the standard theory, but they kept on with it. They weren't done because they still had a dog in the fight. They had inflation, the expansion rate, the Hubble constant. Okay, the Hubble constant was they could hang on with that with the Big Bang because that was data that they knew that it was going to be okay because the Hubble constant, they've been measuring all sorts of shit going off of this particular set of data relating to the Big Bang. They just let all of this go. They didn't know what to do with it, so they just stopped talking about it. Okay, now here we go. We are going to go. Let's see. We need to close this down. Oh, where's my thing?
Other words,
here we go.
The entire.
Shut up, Jonathan. Okay, now here, flash to 2018. Okay, we have the Hubble and Gaia team up to fuel cosmic conundrum. Okay, check this out. Using the power and synergy of two space telescopes, astronomers have made the most precise measurement to date of the universe's expansion rate. The results further fuel the mismatch between measurements for the expansion rate of the nearby universes and those of the distant primeval universe before stars and galaxies even existed. This so-called tension implies there could be new physics underlying the foundations of the universe. That line right there, this so-called tension, implies there's new physics. That means that the physics that they're currently using are wrong, okay? So there has to be some new physics coming, okay? The foundations of the universe. Possibilities include the interaction strength of dark matter, dark energy being even more exotic than previously thought. How that could be, I don't even know, because they don't have a fucking clue what dark energy even is. Or an unknown new particle in the tapestry of space. Combining observations from NASA's Hubble Space Telescope and the European Space Agency's Gaia Space Observatory, astronomers further refine the previous value of the Hubble constant, the rate at which the universe is expanding from the Big Bang 13.8 billion years ago. But as the measurements have become more precise, the team's determination of the Hubble constant has become more and more at odds with the measurements from another space observatory, ESA's Planck mission, which is the Planck mission's just stomping everybody's ass, which is coming up with a different predicted value for the Hubble constant. People, this is huge. Huge. Okay? Planck mapped the primeval universe as it appeared only 360,000 years after the Big Bang. The entire sky is imprinted with the signature of the Big Bang encoded in microwaves. Planck measured the sizes and of the ripples in the cosmic microwave background that were produced by slight irregularities in the Big Bang fireball. The fine details of these ripples encode how much dark matter and normal matter there is, the trajectory of the universe at the time, and other cosmological parameters. These measurements, still being assessed, allow scientists to predict how the early universe would likely have evolved into the expansion rate we currently can measure today. However, those predictions don't seem to match the new measurements of our nearby contemporary universe. With the addition of this new Gaia and Hubble Space Telescope data, we now have a serious tension with the cosmic microwave background data, which there already was flaws. The Planck team member and lead analyst, George, same guy, of the Cavell Institute for Cosmology in Cambridge, England, who was not involved with the new work. The tension seems to have grown in a full-blown incompatibility between our views of the early and late time universe. Let me read that again. The tension seems to have grown into a full-blown incompatibility between our views of the early and late-time universe, said team leader and Nobel laureate Adam Ries of the Space Telescope Science Institute and the Johns Hopkins University in Baltimore, Maryland. At this point, clearly, it's not simply some gross error in any one measurement. It's as though you predicted how tall a child would become after a growth chart and then found the adult he or she became greatly exceeded the prediction. We are very perplexed. Really? In 2005, Rise and members of the SHU's supernova equation of state team set out to measure the universe's expansion rate with unprecedented accuracy. In the following years, by refining their techniques, this team shaved down the rate's measurements uncertainty to unprecedented levels. Now, with the power of Hubble and Gaia combined, they have reduced the uncertainty to just 2.2%. Because the Hubble constant is needed to estimate the age of the universe, this is important right here. The long sought answer is one of the most important numbers in cosmology. And it's wrong. It is named after astronomer Edwin Hubble, who nearly a century ago discovered that the universe was uniformly expanding in all directions, a finding that gave birth to modern cosmology. Galaxies appear to recede from Earth proportional to their distances, meaning that the further away they are, the faster they appear to be moving away. This is a consequence of expanding space and not a value of true space velocity. By measuring the value of the Hubble constant over time, astronomers can construct a picture of our cosmic evolution, infer the makeup of the universe, and uncover clues concerning its ultimate fate. But all the data is wrong. The two major methods for measuring this number give incompatible results. Let me say that again. The two major methods of measuring this number give incompatible results. One method is direct, building a cosmic distance ladder for measurements of stars in our local universe. The other method uses the cosmic microwave background to measure the trajectory of the universe shortly after the Big Bang, and then uses physics to describe the universe and extrapolate to the present expansion rate. Together, the measurements should provide an end-to-end test of our basic understanding of the so-called standard model of the universe. However, the pieces don't fit. Using Hubble and newly released data from Gaia, Rise team measured the present rate of expansion to be 73.5 kilometers per second per megaparsec. I love that word, megaparsec. I might name, well, I'm going to have no more kids. My next cat's going to be named Megaparsec. This means that for every 3.3 million light years farther away a galaxy is from us, it appears to be moving 73.5 kilometers per second faster. However, the Planck results predict the universe should be expanding today at only 67 kilometers per second per megaparsec. As the team's measurements have become more and more precise, the chasm between them has continued to widen and is now about 4 times the size of their combined uncertainty. The more they look into it, the more uncertain the model is becoming. Over the years, Rise team has refined the Hubble constant value by streamlining and strengthening the cosmic distance ladder used to measure precise distances to nearby and far-off galaxies. They combine those distances with the expansion of space measured by the stretching of light from nearby galaxies. Using the apparent outward velocity of each distance, they then calculated the Hubble constant. To gauge the distances between nearby galaxies, this team used a special type of star as cosmic yardsticks or milepost markers. These pulsating stars, called Cepheid variables, brighten and dim at rates that correspond to their intrinsic brightness. By comparing their intrinsic brightness with their apparent brightness, as seen from Earth, scientists can calculate their distances. Gaia further refined the yardstick by geometrically measuring the distance of 50 Cepheid variables in the Milky Way. These measurements were combined with precise measurements of the brightness from Hubble. This allows the astronomers to more accurately calibrate the Cepheids, I'm saying that right, Cepheids, and then use those seen outside the Milky Way as milepost markers. When you use the Cepheids, you need both distance and brightness. Hubble provided the information on brightness, and Gaia provided the parallax information needed to accurately determine the distances. Parallax is the apparent change in an object's position due to a shift in the observer's point of view. Ancient Greeks first used this technique to measure the distance from Earth to the Moon. Hubble is really amazing as a general purpose observatory, but Gaia is the new gold standard for calibrating distance. It is purpose built for measuring parallax. This is what it was designed to do. Gaia brings a new ability to recalibrate all past distance measures, and it seems to confirm our previous work. We get the same answer for the Hubble constant if we replace all previous calibrations of the distance ladder with the Gaia parallaxes. It's a cross-check between two very powerful and precise observatories. The goal of Rees' team is to work with Gaia to cross the threshold of refining Hubble constant to a value of only 1% by the early 2020s. Meanwhile, astrophysicists will likely continue to grapple with revisiting their ideas about the physics of the early universe. Okay, catch this last paragraph right here tells you that they are going to continue to use the flawed model as right now until they can figure out what the fuck they're going to do, because the whole model is screwed. They're telling you that they're using faulty science at this point. They're going to continue using these multi-million-dollar pieces of equipment that are reading false data. The whole Hubble constant is wrong, that they're basing all of their measurements for the entire theory of Big Bang Post is wrong. It's all wrong. And they're just going to continue to use it because they don't know what to do at this point. They've been doing this since the 2000s. Everything they check is wrong. From the cosmic microwave background, they've known there was irregularities and anomalies. Back in the 2000s, they were getting wrong data because the flat universe is actually curved. Everything that they've predicted with the standard model is wrong. So now the Hubble constant is wrong. Where do you go from there? I mean, really, what are you going to do? You can't just keep going with it. You've got to stop and say, look, this is all wrong. We need to get together here on this. I mean, it's like a damn joke. NASA's running a joke. I'm heated. I hope y'all enjoyed this. I'm going to follow up.